Hi, my name is Audrey Miller, and today I'll be presenting on chemical gardens and how their abiotic nature can be determined via novel data collection methods. So first of all, what are chemical gardens? Chemical gardens are inorganic growths made from an anionic solution and a metal salt. So in the case of this experiment, our metal salt was an iron solution and our anionic solution was a sodium silicate solution. Now the reason that we chose this experiment to perform is because there's been a lot of research done on chemical gardens lately. And the reason for that is because chemical gardens are actually very close analogs to hydrothermal vents at the bottom of the ocean. And now the reason that's significant is because hydrothermal vents are believed to be the place where life originated on Earth. So for people looking into extraterrestrial life and the possibility of finding life on other planets and moons, the origin of life here on Earth is a really important question, because if we know how life arose here on Earth, we're able to better understand how life could arise on other planets. Now for this particular experiment, the reason that iron and sodium silicate were chosen is because they're reminiscent of what ancient oceans on Earth would have been like. So you see in this image here, this is the chemical garden that we grew in our experiment. Now, these concentrations of iron and silicate are very dilute. So you see this area towards the bottom, that is the actual formation of the chemical garden. Now in these images, at the top of the poster, those are chemical gardens grown at much higher concentrations of iron and silicate. So you can see there's an obvious difference between the more concentrated gardens versus the less concentrated garden, which looks a little more foggy than an actual structure like the ones pictured up above. And like I said, the reason we chose the more dilute concentrations is because it is more reminiscent of those ancient oceans. Now what we did is, when you grow a chemical garden, you can actually measure things related to that chemical garden. So what we did is we took the redox potential of this garden, because when you form these semi-permeable membranes that form the gardens, you get a pH gradient that can be measured and quantified, which is exactly what we did in this experiment. Now in our results section, when we took that redox potential, you do get a lot of oscillations in the data, and sometimes it's hard to see if there's a trend within that data. So we did a novel method called detrended fluctuation analysis. And what that is you take data with a lot of oscillations, you chop it up into windows, and within each of those windows, you take the linear trend, find the standard deviation of the oscillations from that linear trend, sum them all together, and you get one data point. And as you choose windows of different sizes, you make a graph and a linear trend. And so we did that for both the stagnant iron solution as well as the iron solution while the silicate was being pumped into it, creating the chemical garden. Now the significant part about our data is that this red line that you see here, this is the stagnant iron solution. So the detrended fluctuation analysis on just the iron solution gives you a slope of 1.3. And that number is greater than 1, meaning there's more diffusion than would have been expected for normal solution diffusion, which is a good sign for our experiment because it shows you that our reaction, our experiment isn't actually taking place. Because when you compare it to this black line here, that's our actual experimental data, and the slope of that line is 0.7, which is less than 1, meaning less than normal diffusion is occurring. And this is significant because this shows that we created an abiotic reaction with fluid flow, yet we still get a signal that's very, very different than a biotic reaction. So this shows that detrended fluctuation analysis is a great way to analyze data and determine if it's going to be biotic or abiotic. So just in our discussion and conclusion section, we really wanted to reiterate that yes, detrended fluctuation analysis on a reaction can show you if something's going to be abiotic or biotic. So this entire experiment and the results that we gathered here just contributes to a greater wealth of knowledge in favor of DFA being brought to other extraterrestrial locations in the search of life. So thank you.